In this video, we'll be looking at intercept or factored form of a quadratic equation. In this scenario, a startup company's main source of income is their new mobile app. The company's annual profit in millions of dollars as a function of the app's price is modeled by the function given in intercept or factored form. Using the key pieces of information given to us in factored form and the stem of the problem, we can go ahead and create a graph that looks like such. From this graph, we can see that it opens down. There's an upside down U because there is a negative in front of our graph, causing a vertical reflection. Very similar to how there was a negative in front of our vertex form graph. But in terms of key features, we see that there is an x-intercept at 2, 0, and an x-intercept at 9, 0. Maybe you recognize those values as they were inside of the parentheses in the original equation. And that's the information we can get. So, looking at the key features and questions we want to answer about this particular scenario, at what app price would produce a maximum profit? Well, the feature we're looking for is the h value or the x-coordinate of the vertex, which would be located here. However, we don't know what that is. So unfortunately, this form cannot provide that answer. Well, what about the maximum profit possible for the company? Well, that would occur at this value, the k value, or the y-coordinate of the vertex. Well, we don't know the millions of dollars that they would make as a maximum profit. So vertex form is unable to answer that question. Well, what would the company's profit be if the app price was $0? Well, this is the y-intercept, where we're looking for the key point that shows up on the y-axis. And once again, we'll notice that we are unable to answer this question using vertex form of the quadratic. Well, what app prices result in 0 annual profit? Well, 0 annual profit for the y-axis. Well, we can see that this is actually found from using the x-intercepts, which we were provided from in the equation. So we know that the app prices will result in 0 profit at $2 and $9. If the company sold the app for $2 and $9, they would not earn any profit. Okay, well, what about what app prices cause revenue to increase and what app prices cause revenue to decrease? So looking at the graph, where is the graph increasing and where is the graph decreasing? Well, in order to answer that value, we need to go ahead and find the h value of the vertex, which we were unable to find because it's not provided in the equation. So we are unable to determine increasing and decreasing intervals from intercept or factored form. Well, what app prices cause profits to be positive or app prices to be negative? Well, positive, we need the x-intercepts. Negative, we need the x-intercepts to help us determine where the graph is above or below axis. Well, the x-intercepts provide that break between positive to negative. So, looking in terms of positive, we see we are positive between $2 and $9, and we are negative on the graph from negative infinity to 2 and 9 to infinity. Negative on this portion of the graph and negative on this portion of the graph, and the y values are positive on this portion of the graph. We answer in terms of our x values. We are negative from this arrow, meaning negative infinity to 2, and from 9 to positive infinity. All right. Lastly, we want to think about a reasonable domain for this scenario and a reasonable range for this scenario. Well, for a reasonable domain, we're thinking about what app prices make sense in this scenario. How far left to how far right makes sense in this particular scenario? Well, looking at our x-axis, it doesn't really make any sense to sell the app for anything less than $0. And infinity dollars seems a bit unreasonable as well. So in terms of a reasonable domain, maybe from $0 to $10, or really 0 to the highest amount that you would consider paying for an app. What about a reasonable range? Or in this scenario, what annual profit of millions of dollars would make sense in this particular scenario? How far down to how far up would this go? Well, even though we'd like to say that 0 might be the lowest amount a company could earn, technically companies could go into debt if they don't manage their finances well. So a negative value is reasonable. In terms of highest value, we could see that there is a maximum, but it is currently unknown for us at this time. So answering the reasonable range could get a little tricky. Say that the company could lose up to $100 million, negative 100 million, before they file for bankruptcy, but we don't know what the maximum profit would be, and maybe we need to pull a little bit more information out of this particular problem. So looking back over all the key features and the questions that we were able to answer from this scenario, we can see from intercept or factored form, x-intercepts from a graph. From the x-intercepts, we're able to determine positive and negative intervals, once again remembering that we are writing this in terms of the x's, as well as we could come up with a reasonable domaining range within reason. We know that the graph does max out, but we don't know exactly what value for the range in this particular scenario, and we would need to go ahead and figure out more information and get a more detailed graph, specifically what is that x and y or h and k value of the vertex. But intercept and factored form can provide these three pieces of information relatively easy just from the equation.